All right, so this is Matthew Ehret Kump from Ottawa, Canada, and with me today is Robert Mueller from NASA, who is speaking to us here during the Planetary and Terrestrial Mining Symposium, the 8th annual one. And Robert, maybe you could tell us a little bit about yourself, how you got into the field that you're in, and then we can discuss some of the science that you're pushing for.
Okay, sure. I'm the chief of the Surface Systems Office for NASA at Kennedy Space Center. And so my job is to work on in situ resource utilization and robotics. And so we're trying to develop new technologies and new methods for going out into the solar system and expanding the human presence in the universe.
Okay. Now, could you tell us a little bit how it is that you see the necessity of an optimistic human society in the universe as a basis for economic development, and what your mission is to accomplish that?
Sure. Well, if you look at the history of mankind, it's always been related to resources. And economic expansion has often been part of a search for resources, and essentially people want a better life. And that better life is usually associated with resources that are available in nature, or they're developed, or it may be intellectual property, but it's always something that makes your life better. And so we think that by expanding the human presence into the solar system, our life will actually get better here on Earth. And one of the reasons why is because there are tremendous resources in outer space, much more resources in outer space than we have here on Earth. So that's one good reason to go.
Right. And it's better than just the current paradigm of fighting over scarce fixed resources that currently exist on the Earth, but the creation of new resources that we don't yet even realize exist. Right?
Yes. I mean, energy comes from the sun, and there's plenty of solar energy in outer space. There are plenty of materials in outer space. And so if we can learn to harness the energy in outer space and use the resources in outer space, it will make life better here on Earth, and it will let us expand our economic sphere of influence into the solar system.
Right. Now, you've recently produced a certain competition for varying students around the world that has both a great utility to it, but also a very great inspiring aspect to it as well, in creating a certain culture of optimism. Now, perhaps you could go through both aspects of what this contest was that you presented here at this conference, what you hope to achieve on both levels.
Right. So the current generation of engineers are, we call it the Apollo generation. They were inspired by Apollo. And many people that are in their mid-career level, they saw an Apollo launch when they were young, or they remember their first memory. One of my first memories was seeing Apollo 11 of an astronaut walking on the moon. I was barely old enough to remember it, but somehow it was burned into my brain, and I take it for granted that space is exciting. However, the next generation doesn't necessarily take it for granted that space is exciting. They want to see something exciting. They want to be inspired. They want to feel the excitement. So I put this competition together called the Lunabotics Mining Competition. And the main reason for having it is to ignite the spark, the passion of creating something, of designing something, of designing a robot that can go to the moon and mine the resources on the moon and make life better for everybody. So we have this competition for universities. They build robots and they compete. We had 36 universities that came to Kennedy Space Center, and they were digging lunar regolith. Lunar regolith is lunar soil. Now, 42% of the lunar regolith is oxygen. So if you dig up the lunar regolith, you can extract the oxygen from it, and you can make rocket propellant out of it, which gives you a ride back home. And it also gives you breathing air, and you can make water out of it, and you can drink the water and shower with the water. There's many uses for this water. So we think there's water on the moon, possibly, and there's definitely oxygen on the moon. So this competition is designed to excite the next generation to go and mine the resources on the moon and beyond, so that we can learn how to live in outer space by living off the land.
Now, it has occurred to me that it seems as though that we have found water traces in the moon by looking at this L shot that was conducted very recently by India. but you're saying that it's still a potential phase.
There's evidence that they had neutron spectrometers on satellites that orbit the moon. And these neutron spectrometers indicate the presence of hydrogen. Now, we also had an American spacecraft, LRO, LCROSS was the acronym, and it was an impactor. It impacted a stage into the moon, into a crater, and there's these permanent shadowed regions in the craters that have never seen sunlight in billions of years. And so we think that this is called a cold trap, and we think that these volatiles, things like water and carbon monoxide and possibly methane, have collected in these cold traps because they've been bombarded. The moon has been bombarded over these billions of years by meteoroids, and it's collected in these cold traps. And so the LCROSS mission showed evidence of water in the plume. So we think there's water on the moon. We know there's hydrogen on the moon of some form. And if it is water, that's really the holy grail of space exploration, because now we have the resource we need to go beyond the moon and mine it on the moon and use it for transportation. And it lowers the cost of transportation. By lowering the cost of transportation, it makes space accessible.
Right, so you don't have to actually bring huge amounts of water to the moon.
Right, it's very expensive.
Okay.
So it's the space shuttle costs $10,000 a pound to go to low Earth orbit. Astrobotic, which is a company that just formed to provide transportation to the moon and do missions to the moon, they advertise it $1.8 million per kilogram for a payload delivered to the moon. Okay. These costs are very high. They have to come down. If they don't come down, we'll have a hard time making this economically feasible. So we're working on developing technologies to reduce the cost of space transportation. And ISRU, or in-situ resource utilization, this is one way of doing it.
Right. Now, perhaps you could shed a little bit of light on this problem. A lot of people, when they think of the moon, they think of something that is sort of homogeneously distributed moon dust that has sort of a common characteristic and common density. But is that actually too simplistic? Is there something more profound to the distribution and elements that you'll find on the moon?
Well, we're just learning about the moon. So we've been there 6 times and with humans. And so we're just learning about it. And the common wisdom was that the moon is a homogeneous place due to a process called gardening. So these meteoroids, they come in, they bombard the moon, and over the billions of years, it's just stirred up all the regolith and pounded it into tiny little particles. So it is fairly homogeneous. But every time we go, we get surprises, and we learn more. So when you go prospecting, usually you find that there's minerals in one region, not another region. There are local differential things that happened, and so we don't really know. We need to go. We need to go with a ground truth mission, and we need to discover what exactly the resources are on the moon, and then we can make a plan on how to use those resources.
Right. Now, perhaps you can go through some of the basic science, just for our viewers, pertaining to how do you extract some of these basic minerals from the regolith that's there on the moon. What processes do we have accessible, and what new discoveries or technologies can we yet implement that would allow us to make this happen?
So there's many ways of extracting the resources. It's basically chemical engineering. Okay. Many different ways, and they're based on processes that are used here on Earth today. Now, the simplest one is melting ice. So everybody knows what that is. If you find ice on the moon, water ice, and we go and dig it up, it won't exist on the surface because it would sublime into the vacuum of space. But maybe below the surface there is ice. So we can dig up the regolith and extract the ice and then simply put it in an oven and melt it. And then we can purify it through distillation, and we have pure water. That would be the very simplest chemical process. Now, NASA's working on 3 chemical processes which have different yields. So hydrogen reduction is basically where you take the regolith and you cook it with hydrogen, and water vapor is the result. And you catch the water vapor, condense it, and you electrolyze it to make hydrogen and oxygen. That results in a yield of 1%. So for every 100 kilograms of regolith you dig up, you get 1 kilogram of oxygen. So that's not very efficient. So we have another process called the carbothermal process. Carbothermal process is a little bit more efficient, about 12% oxygen. And then we have the ultimate process, which is molten oxide electrolysis, where you basically melt the regolith into lava, and you have lava and you put electrodes in it, and then the electrodes separate all the different elements, and so you have oxygen going to one electrode, and that's 28% efficient. So these are the technologies we're working on, but we're not there yet. We're still developing those technologies.
Well, it seems like you'll need a lot of energy to harness in order to make these processes happen.
Yes.
Do you see a role for nuclear reactors on the moon to bring you that density of energy?
Well, we have a giant nuclear reactor called the Sun in space, which we can use. The problem is that you can only harness the energy of the Sun during the daytime. The lunar day lasts 14 Earth days, and then the lunar night lasts 14 Earth nights, so or 14 days on Earth. So each lunar orbit is 28 days, and so during that dark period, it's very difficult to survive the lunar night of 14 days. And so if you had an area, which you do have on the poles where there's permanent sunlight, then you can harness the sun permanently that way. To survive the night, you have to have batteries or some other technology like fuel cells. Ultimately, the best technology is probably a nuclear reactor because it's not dependent on the night or the day or the sunshine. It's constant, reliable energy. But there are political problems with launching nuclear substances into space and safety issues, so that has not happened yet.
What role do you see as the development of a permanent manned colony, which is, I think, the intention that we hope to get to on the moon in order to have a further manned space program on Mars, which was originally the intention of people like John F. Kennedy originally, which was, I think, estimated by the 1980s we were supposed to already be there. Now, what do you see as that being a stepping stone?
Yeah, well, think of other remote regions on Earth, like Antarctica. And so there are many ways we can approach the settlement of a remote region. Now, in Antarctica, for example, it's a research station, and scientists go there, and they're funded by their governments, and they do research, and so that's one model. It's a government-funded model. You send scientists there, and they produce science, but it's really small quantities of people and very specialized professions, and it's not economically profitable. So if we do want to truly expand our economic sphere of influence as citizens of the solar system, we have to find a way to make it profitable or sustainable. And that means we have to have a product. And we have to develop something on the moon or in other parts of the solar system that actually make a profit, that are needed. So that's the challenge, is to make a settlement on the moon that can survive by itself. You have to have a product, a commodity, and you have to be self-sustaining, which means you have to live off the land. Otherwise, you'll be having these giant logistic trains, these rockets coming from Earth all the time that deliver your supplies. Now, in the short run, you can do that, but in the long run, you must find ways to live off the land.
Right. I suppose in the long-term scheme of things, the idea of eventual terraforming of Mars has to also become a serious consideration that we no longer hear that much discussion about.
Well, Mars used to have an atmosphere and oceans, and the evidence indicates there was lots of water on Mars with a climate, and so it was a healthy planet. So what happened to Mars? That's the question. Was there life on Mars? What happened to all that water? What happened to the magnetic core? Did the magnetosphere disappear? Did the atmosphere blow away? Is the water still there, but it's frozen underground? These are all questions we're trying to answer. Is there life on Mars? Is it geologically alive? Maybe under the surface there are bacteria growing there. We don't know. So these are all questions we're trying to answer, and we won't be able to answer them until we actually go there and study it.
Right, and that requires a shift in policymaking, too, from the current view, which is more of the bailout speculators on Wall Street and slash the budget and everything productive, towards something that actually puts money as a domesticated feature for human development of the future.
It requires a long-term vision. And if you get caught up in the daily grind and you don't have a long-term vision, then inevitably human greed takes over and you get these things happening like on Wall Street. But if you have a long-term vision, it puts humanity into perspective, and it puts your personal goals into perspective. And this may be a multi-generational thing. The pyramids weren't built in one generation. This may take many generations. And in order to have something like this, for the torch to be passed from one generation to the next generation, you have to have a vision. And so that's why we're doing Lunabotics, is to pass that torch on from one generation to the next, keep the excitement alive, keep the vision alive, keep the spirit alive. And ultimately, our destiny is to expand into the universe. I think that's just the nature of humans, is they're curious and they want to explore.
Right. And no other species of animal that we've yet discovered in the biosphere can possibly contemplate what's the purpose of my existence in the grand scheme of things, and what can I do for my future zebra great-grandchildren.
Not that we know of.
So I think with that, I appreciate very much you giving your time for this interview, and I hope there's many interviews in the future to be had as well.
Well, thank you, and thank you for coming to our conference, and it's been a great meeting.
Thanks. Ciao. All right, so this is Matthew Ehret Kump from Ottawa, Canada, and with me today is Robert Mueller from NASA, who is speaking to us here during the Planetary and Terrestrial Mining Symposium, the 8th annual one. And Robert, maybe you could tell us a little bit about yourself, how you got into the field that you're in, and then we can discuss some of the science that you're pushing for.
Okay, sure. I'm the chief of the Surface Systems Office for NASA at Kennedy Space Center. And so my job is to work on in situ resource utilization and robotics. And so we're been part of a search for resources, and essentially people want a better life. And that better life is usually associated with resources that are available in nature, or they're developed, or it may be intellectual property, but it's always something that makes your life better. And so we think that by expanding the human presence into the solar system, our life will actually get better here on Earth. And one of the reasons why is because there are tremendous resources in outer space, much more resources in outer space than we have here on Earth. So that's one good reason to go.
Right. And it's better than just the current paradigm of fighting over scarce fixed resources that currently exist on the Earth, but the creation of new resources that we don't yet even realize exist.
Yes, I mean, energy comes from the sun, and there's plenty of solar energy in outer space. There are plenty of materials in outer space. And so if we can learn to harness the energy in outer space and use the resources in outer space, it will make life better here on Earth, and it will let us expand our economic sphere of influence into the solar system.
Right. Now, you've recently produced a certain competition for varying students around the world that has both a great utility to it, but also a very great inspiring aspect to it as well, in creating a certain culture of optimism. Now, perhaps you could go through both aspects of what this contest was that you presented here at this conference, what you hope to achieve on both levels.
Right. So the current generation of engineers are, we call it the Apollo generation. They were inspired by Apollo. And many people are trying to develop new technologies and new methods for going out into the solar system and expanding the human presence in the universe.
Okay. Now, could you tell us a little bit how it is that you see the necessity of an optimistic human society in the universe as a basis for economic development, and what your mission is to accomplish that?
Sure. Well, if you look at the history of mankind, it's always been related to resources. And economic expansion has often